Applied Science. This is Mr. B. To start section 4 here, we're going to move to what is called the outer solar system. So we did the inner solar system, which consisted of Mercury, Venus, Earth, and Mars, and now the outer solar system is going to consist of some planets a little bit farther away from the Sun. So again, as our little example, they always do at the beginning talk about Uranus and how it was discovered in 1781. Again, some of those telescopes that were used back then, but the rings around it were not discovered until 1977. Again, they were discovered by accident, which we'll talk more about that when we talk about Uranus later on. Again, this is a false color infrared image that was taken by the Hubble Space Telescope. Again, captures the rings and the colors. Again, they add the colors to show different contrasts. Again, that's what the false color image is. Again, just to give us an idea of kind of some different components that might make that up. So with the outer solar system, a big term you're going to need to know are gas giants. That is a big term that will kind of rear its head a lot. The 4 gas giants are thought to have small, dense cores and thick atmospheres, and they're mostly made of hydrogen and helium. So this is what makes a gas giant a gas giant. They have, again, small, dense cores, thick atmospheres, mostly hydrogen and helium. Again, we'll talk about this more as we go through this. So our 4 gas giants, which this is something important you probably need to write down as well, Jupiter, Saturn, Uranus, and Neptune. Again, those are our gas giants, and they're very different from the terrestrial planets that are found in the inner solar system. First off, which kind of just some common sense stuff here, they are in fact much colder because of their distance from the Sun. Again, farther away from the Sun, less heat from the Sun, meaning you're going to be colder. Again, they are much larger and much more massive than the terrestrial planets. So again, the size difference is very big there. And they are often referred to as the gas giants, which we said in the previous slide, because they're mostly composed of hydrogen and helium. Again, two gases that make a gas giant a gas giant. Again, another important thing you probably need to write down there. Again, the 2 main gases that make up the gas giants there. Again, to kind of go along with this name, gas giants do not have solid surfaces. In fact, it says if you tried to land a spaceship on one, you would sink into the planet until the intense pressure of the atmosphere crushed the ship. So there's no solid surface for it to land on. Again, you could try, but the atmosphere, again, the pressure is just so great that the atmosphere would crush anything you sent in there. Again, in fact, the pressure is so great that inside each planet, the hydrogen and helium that is there most likely exists in a liquid form. So again, you have to have extreme low temperatures or extreme high pressure to kind of compact hydrogen and helium down enough to make it exist in a liquid form. So that just kind of shows you the immense amount of pressure that is present on those planets. There are gas giants. Again, the gas giants have many moons, which again is kind of another contrast to our terrestrial planets, which have very few, if any, moons, most of which will revolve in the same direction that the planets rotate. And then also another kind of characteristic feature there of the gas giants is that each is surrounded by a ring. And what the rings are, which I'm sure, again, if you think of Saturn, Saturn is like the most distinct planet that has a ring associated with it. The ring is a disk made of many small particles of rock and ice that orbit around the planet. So that's probably an important word you need to know, that the rings that are actually see, again, and think of Saturn, you see a ring around it. It's small particles of rock and ice that orbit the planet. The rings are so close to the planet that the gravitational forces are very large, which may have prevented the ring particles from clumping together to form a moon. So they are closer, in closer proximity to the planet, that the gravitational pull kind of just kept them exactly where they were. So the gravitational pull from the planet did not allow them to clump together. It held them exactly where they are and exactly where they need to be to form those rings. Again, the outer planets consist of the 4 gas giants. Pluto, again, is in there. However, it was reclassified as a dwarf planet in 2006. And like I said, I think that has changed multiple times here. But for now, I think it is back to Pluto is in fact considered to be a dwarf planet. And again, this is a similar chart we had with the terrestrial, the inner planets. Again, you don't need to really write that down. Again, if this would just be more like giving you all this and answer questions like looking at this chart, how many moons are on Uranus, and then you'd be able to go over 27, and then comparing how long it takes one to revolve around the Sun in Earth years and things like that. So again, don't worry about writing this down yet. So the one gas giant we're going to talk about today, that's we're actually only going to talk about one, is Jupiter. And Jupiter has a lot of interesting things going on with it because it is the largest and the most massive planet in our solar system. Um, and just some characteristics of Jupiter, and more specifically its atmosphere to start here. Jupiter's clouds move rapidly because Jupiter itself rotates rapidly. One day on Jupiter is less than 10 Earth hours. So for Jupiter to rotate on its axis there, it only would take 10 Earth hours again, where it takes 24 Earth hours for ours to do that. Um, there are different colored bands, which we're going to see here in a moment when I pull up a picture here of Jupiter. The brown cloud bands, they are colder and they move faster around the planet than the white bands. So that's just kind of another feature there. Like I said, we'll see with a picture here in a second. Sometimes storms occur at the boundaries between those brown and white bands. And one in particular storm, there's what is called the Great Red Spot. This is kind of a really interesting kind of defining feature of Jupiter here. There's what's called the Great Red Spot, and it is a huge storm that rotates its own center, that rotates around its own center like a hurricane. It is caught between two bands of winds that are blowing in opposite directions, so it's basically just this big continuous storm that's kind of moving around the planet there. It was first observed in 1664, but it may in fact be much, much older. So again, this Great Red Spot, it's always there, but it kind of can move around in different spots depending on where the storm takes it. So here again, here's these brown bands up here at the top. Again, the white bands right here. Again, storms will happen here on these boundaries, and then right down here is the Great Red Spot, and the storm is actually much larger than the size of Earth itself. So this storm, again, it doesn't look like it's that big on this whole, this whole image of Jupiter here. Again, I'm sorry, this model of Jupiter, which is based on photos taken by Voyager 1. Again, the Great Red Spot, again, a giant storm that's constantly going on. Again, first discovered in 1664, maybe much older, and probably still be going on for a much longer time as well. And Jupiter's moons, another kind of very interesting thing about the gas giants is how many moons they have associated with them. Again, they're so much larger and they have more gravitational pull that they're going to have more moons. Again, there's 63 of them again on Jupiter. Most of them are small, which is less than 200 kilometers in diameter. Just to give you just kind of some comparison here, there's a moon called Ganymede and Callisto, and they're similar in size to Mercury, so they have moons that are the size of planets. Io, that's how you pronounce this one, Io, literally Io, is covered with actively erupting volcanoes. Then Io and Europa are somewhat smaller, which they're about the size of our moon. So these are kind of some of the more famous ones, and then they do give you kind of some more defining characteristics of those. Ganymede, Io, and Europa have metal cores and rocky mantles, so their composition is similar to those of the inner terrestrial planets. Io is covered, so that's kind of a big thing with Io. It's covered with actively erupting volcanoes. So that's probably, if you needed to know something about Io, that's probably how volcanically active it is. Ganymede, Europa, and Callisto are covered with ice, and to kind of go along with that, Europa, this would be one that you would definitely need to write down. Europa, it has an icy crust that appears to rest on top of a liquid saltwater ocean. So, again, top crust made up of ice. However, they believe, again, just by the way it moves, that there's a liquid saltwater ocean beneath it, and because of that liquid water, scientists hypothesize that Europa would be the most likely place in our solar system other than Earth to support life. Again, we have not found anything on there yet to support that hypothesis, but and again, we're not talking about giant creatures again, green creatures flying spaceships. We're probably talking about some form of bacterial life, something small that might have been able to come to existence within that saltwater ocean that is present there on Europa. And here's a couple other the two main ones. Io, again, and then this is another thing which I did not hit on. This said it's volcanically active. It is in fact the most volcanically active body in the entire solar system. So that would be something you would need to write down. And it's in volcanic eruptions, consists mainly of liquid sulfur, so that seems very unpleasant. So that's kind of what's going on this moon right here. Again, Europa may have a liquid water ocean beneath its icy surface. The dark lines are wide fractures in Europa's crust, so these lines right here where there's breaks and where you possibly might be able to kind of give the idea that the way that these breaks and the things move, that there might be a saltwater ocean there. So that's it for the beginning of our gas giants. Let me know if you have any questions.